WS2020. This is our supplier management lecture on MBW7. And we're gonna be looking at a couple models today for inventory control. Okay, well, inventory, as you know, is essential to provide flexibility in an operating system. It can be classified into raw materials, work in progress, and finished goods. Okay, so we have our process, and or better, we have our process here and our process steps. Okay, and so we can find inventory within the process as raw materials are and finished goods. So this is raw material, this is work in progress, and this is finished goods. Okay, so far nothing new. You should know this perfectly. Okay, so the main function of inventory or functions of inventory are smooth or smoothing out irregularities, in supply, okay, so reducing, this means reducing process and in the end supply variability. Remember always that the variability is measured on the first momentum to the mean value. Okay, this is the standard deviation variability. The second utility of inventory is minimizing cost. Okay, through the lot size. And the third is allowing organization with to cope with perishable materials. So the basic, those are the main functions, the classification, and why do we need it. The main inventory decisions are as follow. When should the inventory of an item be replaced? Number 2, how much of an item is to be ordered when the inventory of that item has to be replenished. Okay, so those are the two main inventory decisions that management or supply chain managers make. So, any questions so far? There is an obvious cost trade-off. In inventory. So if we place frequent orders, the cost of each order will increase, but the inventory carrying cost will decrease. Remember, always remember the EOQ model that we have seen in the past. Okay, this is just saying that if this is the quantity that we order and this is the cost function, we have here the cost of, or the carrying cost. Okay, this is the carrying cost function, carrying cost, and we have also the cost of placing an order, the cost of each order, and the total cost will be just the sum of it. The minimum is achieved where both curves cut. So we call this the optimal economic order quantity. Q star, we have done this before, and today this is based on certain assumptions, and the assumption is that we have instant replenishment and stuff like that. We will see more models today about this. Okay. If we have so the model number 1 is the purchase model with instantaneous replenishment and without shortages. So this is the ideal. The first of the models, we have seen this, so that's why I don't do it very detailed. You can go back and watch the videos before. In this model of inventory, orders of equal size are placed at periodical intervals. The items against an order are replenished immediately, instantaneously, and they are consumed at a constant rate. So the purchase price per unit is the same irrespective of order size. So under these premises, if D is the annual demand in units, per year, C sub 0 is the ordering cost per order, C sub C is the carrying cost per unit per year, P is the purchase price per unit, remains constant, and Q is the order size. Then we have something like this. The model behaves like this. So this is the number of units. This is time. And then we have Q, which is my order size. And then we have something that the inventory level goes like this. Bam. And then goes up again instantaneously, and then goes like all the time. Okay, and this is T. Okay, so we know already that this model has a solution of 2C0 times T divided by ZZ. The number of orders equal D divided by Q star, and the time between orders T is Q star divided by D. We know this, okay, so I am not going to repeat it because it's already known. Today I'm interested in other more complicated models. So far as an introduction, any questions? No questions, okay. So model number 2. Model number 2 is the so-called manufacturing model. Without shortages. If a company manufactures an item which is required then the corresponding model is called manufacturing model. So we saw the other day the make or buy decision. This is the case that we make, okay? Here the assumptions are the same as those of model 1, except that of the instantaneous replenishment. We assume that each production run length T consists of two parts. So T is equals T1 plus T2 such that the first one, the inventory, is building up at a constant rate of K minus R. I explain later on what all this means, these parameters. Units per time unit during T1. We assume that K is bigger than R. And 2, there is no replacement during T2, and the inventory is decreasing at a rate R units per time. So the graphic looks a little bit like this. This is time. These are the units. Okay. And then we have the curve. So here the slope is K minus R, and here the slope is R. Notice that the slope is different, okay? So this is T1, this is T2, slope while we produce, okay, and take inventory R. Slope while we take inventory. R. So this goes ad infinitum, always the same, okay? So always having peaks and going up and down and up and down and up and down. So basically, in the time frame (0 to T1, we replenish, we produce at a speed of K units per time, and simultaneously we take inventory, we deliver the inventory at speed, at rate R units per time. That's why the total rate is K minus R. Similarly, in the time frame T1 to T2, we do not replenish anymore. Because we have already achieved Q, which is our maximum. We only take inventory at speed R units per time. Okay. Does it make sense? The parameters are explained like this. R is the annual demand in units per day. D is the annual demand in units per year. K is the production rate of an item. Okay, in units per time unit. Units per time. T1 is the period of production and consumption. And T2 is the period of consumption only. Okay. Here, the total order Q is produced over a period of time T1, which is given by the production rate K the average inventory level, well, Q, of course, Q is this, okay? Q is this big number of units produced, okay? The average inventory level would be determined not only by the lot size inventory, lot size inventory, Q, but also be affected by the production rate K and depletion, the demand rate R. So in order to determine the average inventory, we do the following. Since T1 is the time that it takes to produce Q at a rate K, we have that Q equals K times T1. Okay. During production time T1, inventory increases at the rate of K and decreases at the rate of R. Thus, inventory accumulates at the rate of Q minus R. Therefore, the maximum inventory level shall be equal to T1 times K minus R. So as a result, the average inventory equals 1 divided by 2 times T1 times K minus R, and this equals 1 divided by 2 Q times 1 minus R divided by K, because we know from before that T1 is Q divided by K. Okay, so this is the average inventory. Now, with C sub 1 as the carrying cost per unit, C sub 1 or wait, how do we do it? C sub 1? Yeah, let's call it C1. Carrying cost per unit per year comma it's not responding. Wait a minute. My pencil is not responding. Wait a second. Plug it in. Okay, I have some sort of technical problem. I will make a little break and then continue in a minute. Okay. We continue in 5 minutes. Okay, we continue now then. We have the average inventory equals 1 divided by Q, 1 divided by 2 times Q times 1 minus R divided by K. And if we call C1 the carrying cost per unit per year, then the total annual holding inventory cost is given by F of Q equals the average inventory times C1, which equals then 1 divided by 2 times Q times C1 times 1 minus R divided by Q. And the annual ordering cost is given by G of Q, which is CS times D divided by Q, where D is the demand, annual demand, as we saw before, in a year. Okay. As we had, the minimum total cost occurs when the annual ordering cost G of Q and the annual holding cost F of Q are equal. Thus, the Q star satisfies that f of Q star equals G of Q star, meaning that this is the economic order quantity, okay, Q star as before. So this means that 1 divided by 2 times Q star times C1 times 1 minus K, R divided by K equals CS times D divided by Q star. So we have that our economic order quantity in the manufacturing model equals 2 times CS D divided by C sub 1 times 1 minus R divided by K. And this formula was used last week. Maybe you remember. When we talked about make or buy decisions. So as a result, the optimum number of production runs per year is number n sub 0 is D divided by Q star, or n sub star better. And this is D times C1 divided by 2CS times K divided by K minus R. Okay. The optimum length with n of each lot size production run T sub 1 star equals Q star divided by K, and this is equal to 2 times CS divided by C1 times K minus R. And the total production minimum cost is total cost star, or Y, say Y of Q star, equals CS times D divided by Q star plus 1 divided by 2 Q star C1 1 minus R divided by Q by K. This is equal to 2 times D CS C1 1 minus R divided by K. So note that if K tends to R, then one minus R divided by K tends to 0. And this shows that there is no carrying, holding, or setup cost. And then note also that if K tends to infinitum, then 1 minus R divided by K tends to 1, and this gives model number 1. So if the production, the time it takes to replenish production is infinitum, then we have instantaneous replenishment, and as a result, so K tends to infinitum, or R is 0, so instantaneous replenishment, and then we have model number 1. Okay. Questions? So example, a contractor has to supply 10,000 bearings per day to an automobile manufacturer. He finds that when he starts a production run, he can produce 25,000 bearings per day. The cost of holding a bearing in a stock per year is €2, and the setup cost of a production run is €1,800 per time. Okay. So question, how frequently should production run be made. Okay. Solution. Demand equals 10,000 times 300 working days, assuming that 1 year has 300 days. Okay. This means production is 300,000 bearings. Demand. Okay. 10,000 units per day and 300 days of production. Okay, so C1 is 2 euros per unit. CS is 1,800 euros. R is 10,000 units per day. K is 25,000. So you need to understand all the concepts. Okay. So as a result of all the things we know, if I ask this in the exam, of course, you need to make sure that you derive all the formulas that we already had. Okay, so I just here for the exam, please, in the exam, please do the whole formula as above. Just applying the formula is not going to give you points. Okay, so 2 times CS times D divided by C1 times K minus R. And this equals 94868 units. Optimum length of time between orders, T sub 1 star is Q star divided by K, so around 4 days. So this is 94868 divided by 25,000. Okay. And this is basically the how frequently should production run be made. Okay. Any questions? Well, then we make a little break and we continue in 10 minutes. Dann das dritte Modell auf. We build up the third model, sorry, in English, the third model, which is going to be the purchasing model, so the buy version. Okay, it's not make, now it's buy. Okay. So this is called purchase model with shortages. And this models the situation in which shortages can occur. The company buys the product. We assume all the situation of model 1 except that shortages are allowed. So let C sub 2 be the shortage cost per unit of time per quantity. Then the inventory situation can be graphed like this. Now we have shortages, so the inventory can go below 0. This is time. This is the units, the inventory. And now we have a situation in which we can go to 0. Now we have instant replenishment because the situation is the same as with 1. Okay. So this is the situation. In this case, this is T1. This amount of time is T2, so that the total time is T equals T1 plus T2. Okay, and the total quantity is Q1 plus Q2. Okay, so Q equals Q1 plus Q2. Okay. The total period is 1 year and is divided into 2 equal parts of interval t. Okay, this interval t is divided into 2 parts, T1 and T2, so that T equals T1 plus T2. During interval T1, the items are drawn from the inventory as needed. Oops, sorry, I lost my pencil. I hope it still works. And during interval T2, orders are placed but not filled. So this is the situation of a shortage. Okay. An amount of Q is delivered after time T, and the amount of Q is divided. Q is divided into Q1 and Q2. So Q equals Q1 plus Q2, where Q1 denotes inventory and Q2 denotes unfilled demand. Okay, so far, can you follow? So the total inventory over a time period T equals 1 divided by 2 times Q1 times T1. This is the area of the triangle. I painted in green. Sorry, area of the triangle. The area of the triangle is this. This is the total inventory, is the T1 times Q1 divided by 2. Okay. Is that cool? So the average inventory at any time equals 1 divided by 2 times Q1 times T1 divided by T. And the average inventory holding cost equals C1 times 1 divided by 2 times Q1 times T1 divided by T. Similarly, the amount of shortage over a period of time T equals 1 divided by 2 Q2 times T2. This is the area of the triangle. I paint this triangle now violet, let's say, okay. So the sortage is this T2 times Q2 divided by 2, the area of a triangle. The annual sortage cost equals C2 times 1 divided by 2 Q2 T2 divided by T, just the same as before, okay, same logic. And the annual cost associated with runs of size Q is N times CS, and N is the number of runs, so D divided by Q times CS. Therefore, the total annual cost is given by Y of Q times 1 divided by T times C1 times 1 divided by 2 Q1 T1 plus C2 times 1 divided by 2 Q2 T2 plus D divided by Q times CS. Because of geometry, so basic geometry, I paint here the curve again. This is time, and this is the demand curve, or no, the inventory curve, sorry. This is T1, this is T2, and this is the total time, T. This is Q1, this is Q2, and this is the total Q. Okay. The triangle, because of the triangle relationships, there are similar triangles. T1 divided by T is equal Q1 divided by Q. Because both triangles are similar. So T1 divided by T is the same as Q1 divided by Q. Basic geometry. So and T2 divided by T equals Q2 divided by Q. As a result, we have that T1 equals Q1 times T divided by Q, and T2 equals Q2 times T divided by Q. So putting this into the formula above, the total cost, the total annual cost equals 1 divided by 2 C1 Q1 square divided by Q plus 1 divided by 2 C2 Q2 square divided by Q plus CS D divided by Q. Okay. And in order to determine the best values of Q1 and Q2, we just have to now we determine the optimum values of Q1 and Q so that Y of Q is minimum. So in order to get the minimum, we just make the partial derivative of the function to Q1. This equals 0. So as a result, 2 times 1 divided by 2, Q1 divided by Q plus C2 times 2 Q1 minus Q divided minus Q big divided by Q equals 0. And then we get that C1 times Q1 divided by Q plus C2 Q1 minus Q divided by Q equals 0. As a result, we get that C1 times Q1 plus C2 times Q1 minus Q equals 0. So as a result, we get that Q1 equals Q times Q big Q times C2 divided by C1 plus C2. And so this is the first one. This is the optimum value of Q1 and in order to get the optimum value of Q, we make the partial derivative of Q of the cost to Q big equals 0, and this takes us to following. Minus C1 divided by 2 times Q1 square divided by Q square plus C2 divided by Q by 2, sorry, times 1 plus Q1 square divided by Q square times minus 1 minus 0 minus CS D divided by Q square equals 0. This is minus C1 divided by 2 times Q1 square divided by Q square plus C2 divided by 2 Q square minus Q1 square divided by Q square minus CS D divided by Q square equals 0. And this turns out to be that C2 times Q square equals C1 Q square, no, C1 Q1 square plus C2 Q1 square plus 2CSD. As a result, we get that Q, the best Q is 2CS times D plus C1 Q1 square divided by C2 plus Q1 square. Okay. So if we finalize, we get that the optimum quantities are Q star equals 2CSD divided by C2, which multiplies C1 plus C2 divided by C2, and Q1 square equals square of CS divided by C1 plus C2 square 2CSD divided by C1. As a result, the characteristics of the model are as follows. Time between receipts of order T equals, or the best T star, okay, is Q star divided by D. The optimum order quantity is square of 2CS D times C1 plus C2 divided by C2. The total optimum inventory cost equals square root of 2D CS C1 times C2 divided by C1 plus C2. And the maximum inventory level equals Q, maximum inventory level is equals Q star minus Q1 star, and this is equal Q star times 1 minus C2 divided by C1 plus C2 equals 2CSD divided by C1 times C2 C1 plus C2. The period of positive stock is T1 star equals Q1 star divided by D. and the period of sortage is T2 star is T star minus T1 star. Okay. So an example. The annual demand for a component is 7,200 units. The carrying cost is 500 euros per unit per year. The ordering cost is 1,500 euros per order. The sortage opportunity cost is 200 euros, 2,000 euros per unit per year. So find the optimal economic order quantity, Q star, maximum inventory, maximum sortage quantity, cycle time, this the time between receipt of order is also called cycle time. Okay. Cycle time, the period of positive stock, the period of sortage. Okay. So demand is 7,000 solution. 7,200 units per year. C1 equals 500 euro per unit. C2 equals 1,500 euro per order. CS. And C2 is 2,000 euro per unit per year. So the EOQ of Q star, or Q star, okay, equals square root of 2 times CSD divided by C1 times C1 plus C2 divided by C2. Remember, in the exam, if I ask this, you need to be deriving the whole information. So you have D, you have CS, you have C1, you have C2, and it turns out to be 233 units. Okay. So the maximum inventory level Q1 star equals to CS times D divided by Q1 times C2 divided by C1 plus C2. This is approximate, okay. And this is around 186 units. The maximum stock out is Q2 star is Q star big, sorry, minus Q1 star equals 47 units. Period of positive stock T1 star equals Q1 star divided by D equals 186 divided by 7,200 times 365 days equals 10 days. So here 1 year is 365 days. Okay. The period of shortage equals T2 star equals T star minus T1 star equals the cycle time T star is Q star, Q big, make it always small, sorry, Q star divided by D. This is the cycle time minus T1 star. We have it already, so Q1 star divided by D. This is 12 minus 10 equals 2 days. Okay. All right. Well then, this is about it today. Do you have any questions? Good. Then thank you for attending the class. All the material is uploaded on the website in a couple minutes. And next week, this is important maybe, next week I will perform a Q&A. So you can ask your questions next week on the YouTube channel. Making sure you put on the videos the minute and the second of your question in which I say something that you don't understand. So on each video, please make a comment with your question before Wednesday so that I can prepare. Before Tuesday next week in order to prepare, okay? So, and then we go through all your questions from all the semester until today. Is that cool? So make sure you prepare for the questions in the Q&A session. All right. Well then, thank you very much, and stay safe.